high-present polarimetric ITOF to measure high-fidelity depth through scattering media. An indirect time-of-flight camera emits sinusoidal signals and receives reflected signals. Then the measured intensity change depends on phase, which is proportional to the distance between the camera and an object. By calculating per pixel phase shift from the captured intensities, we can obtain a depth map of the scene. However, in the scattering media such as fog, the depth of the target object cannot be measured correctly because the signals reflected from the object and the scattering media interfere with each other. To solve this problem, we propose a depth map correction algorithm for ITOF imaging by means of scattering-aware polarimetric phasor model. Our method can capture correct depth map even in fog environments.
Today I will present our work hair step for single-view 3D hair modeling. The goal is to reconstruct strand-level 3D hair model from a single image. Inspired by the advances of learning-based shape reconstruction, 3D strand models are generated by neural networks as explicit point sequences. Volumetric orientation field, and implicit orientation field from single-view input. With the above evolution of 3D hair representations, the quality of recovered shape has been improved significantly. As populating pairs of 3D hairs and real images is very challenging. Existing learning-based methods are just trained on synthetic data before applying on real portraits. However, the domain gap between synthetic data and real images greatly hinder the success of high-quality reconstruction. Our hair step is proposed to address the issue of this domain gap.
We present a methodology and dataset for 3D human reconstruction from single high-resolution image, named 2K2K. Overview of our work is divided into two main parts. First, we constructed a dataset of 2,000 human subjects to reconstruct high-quality human models. These subjects were captured with high-resolution DSLR cameras, resulting in highly detailed 3D normal, depth, and mesh, as well as SMPL and keypoint information. To maximize the strengths of our dataset, we propose a part-based method to reconstruct high-quality human models using 2048 resolution images. The methods of reconstruction of a 3D human model from a single image goes through the following process. First, from a photo containing a person, we predict the signed distance function values through a deep learning network, pass it through the marching cube algorithm, and form an 3D human mesh. The first paper to propose such a methodology was PIFU, which learned the
Hello, my name is Luke, and I'll be presenting PC², Projection Conditioned Point Cloud Diffusion for Single Image 3D Reconstruction. This is joint work with Christian Ruprecht and Andrea Vidaldi at the Visual Geometry Group at the University of Oxford. I'll begin with a summary. In this work, we propose a novel approach to single-view 3D reconstruction, which generates a point cloud via a locally conditioned denoising diffusion process. I'll start with introduction and motivation, and then describe our method, experiments, and future work. Single-view 3D reconstruction is a fundamental and challenging problem in computer vision. In the case of a single view, the reconstruction problem is highly ill-posed, and as a result, the task requires some sort of semantic understanding obtained by learning. Yet despite the difficulty of this task, humans are adept at using a range of monocular cues to infer the 3D structures of.
Hello everyone, I'm Lipu Zhou. Today I'm going to introduce our work, efficient second-order plane adjustment. Planes ubiquitously exist in man-made environments, so planes are generally used in 3D reconstruction for depth sensors such as RGB cameras and LiDARs, as demonstrated by the following examples. This paper focuses on the problem of estimating optimal planes and sensor poses to minimize the point-to-plane distance, referred to as plane adjustment, or PA. In PA, planes and poses are jointly optimized. Planes are the counterpart of points in bundle adjustment, or BA. Thus, the relevant solutions for the BA problem can be directly applied to the PA problem, but the PA problem has its own characteristics. We present an efficient second-order optimization algorithm for PA.
I'm Matteo Farina, and in this video I will present our CVPR 2023 work, Quantum Multimodal Fitting. On the one hand, in this work we introduce QMF. QMF starts from the notion of preference matrix and follows the steps to solve problems with AQCs. In the first step, a logical graph is obtained with a QUBO formulation. In the second step, the logical graph is mapped to the QPU topology by means of a procedure called minor embedding. In the final step, the AQC undergoes an annealing process, terminating in a state that represents the retrieved solution. On the other hand, we introduce DQMF. DQMF partitions a multimodal fitting problem into equally sized independent subproblems.
Hi everyone, welcome to our presentation, WED for Real, a real-world large-scale dataset for vehicle-to-vehicle crowd perception. This work is majorly supported by UCLA Mobility Lab. Here is the agenda today. So let's summarize the whole work first. In this paper, we propose the first real-world large-scale vehicle-to-vehicle perception dataset WED for Real. It features with, first, it is collected by two vehicles simultaneously in the same location, providing multi-view sensor data stream. Second, it covers 410 kilometers of the driving area with 20K LiDAR, 40K RGB images, and 240K annotated 3D bounding boxes across 5 vehicle classes. It includes diverse route tests.
Hi, my name is Guiwei Zhang from currently a PhD student at Beijing University of Aeronautics and Astronautics. Today, I will introduce our CVPR highlight paper, which is titled as Patchwise High-Frequency Augmentation for Transformer-Based Person Re-Identification. Although recent studies empirically show that injecting convolutional neural networks into vision transformers can improve the performance of person re-identification, the rationale behind it remains elusive. In this paper, we explore possible reasons from a frequency perspective, which is of great significance in digital image processing. As shown in Fig. 1, we first employ discrete Haar wavelet transform to decompose original person images into low-frequency components and high-frequency components. Then we conduct comparisons between the RES and ET101 and trans-readon.
Hello everyone, I am Han Xue from Shanghai Jiao Tong University. Today I'm excited to share our work entitled Freestyle Layout Image Synthesis. First, I would like to give you a short 1-minute overview. In this work, we introduce a new task called Freestyle Layout Image Synthesis, which aims at generating unseen semantics onto a given layout. To this end, we propose a powerful model called FreestyleNet. It leverages a pre-trained text-to-image diffusion model and applies a novel rectified cross-attention to integrate layout. FreestyleNet manages to put a wide variety of semantics described by the text prompts onto the given layout. Its high freestyle generation ability can be demonstrated from these examples, including binding novel attributes, generating novel objects, and rendering the image with novel styles.
Creative workflows for generating graphical documents involve complex and related tasks, such as aligning elements, retrieving appropriate images, or choosing aesthetically harmonious colors. In this work, we attempt at building a heuristic model that can jointly solve many different design tasks. To do so, we propose FlexDM, which is short for Flexible Document Model. FlexDM's key idea is doing masked field prediction in multimodal document domain as a unified interface. With this view, various design tasks can be represented by just changing a masking pattern. We experimentally show that FlexDM successfully solves various design tasks, and here is an example.
Hello everyone, I'm Chenling from Stanford University. I'm very happy to be here to present our work on distillation of guided diffusion models. This is a joint work with Robin, Ricky, Dirk, Stefano, Jonathan, and Tim. In this paper, we propose a distillation-based approach that significantly improves the inference speed of guided diffusion models on high-quality image generation and editing. Classifier-free guided diffusion models have been recently shown to be highly effective at high-resolution image generation, and they have been widely used in large-scale diffusion frameworks including DALL-E 2, Imagen, and Stable Diffusion. A classifier-free guided diffusion model consists of a guidance strength parameter W, which is used to trade off between sample quality and diversity. It also contains two diffusion.
Hello everyone, let me introduce our work, Node Image Compression with Mixed Transformers and Architecture. Node Image Compression methods have exhibited promising progress and superior rate distortion performance. In this paper, we try to incorporate the local modeling ability of CNN and the non-local modeling ability of transformers for image compression. Additionally, drawing inspiration from advancements in entropy estimation models and attention modules, we propose a channelized entropy model with parameter-efficient spin transformer-based attention modules by using channel squeezing. Our experimental results showcase that our proposed method achieves SOTA rate distortion performance across three distinct resolution datasets. Image compression plays an important role in many fields.
Hi everyone, I am Wenai Wang. Here is the introduction of our CVPR 2023 paper in Turn Image, which is the core work of our General Foundation Large Model Project. If you are interested in our paper, please come to see our poster on June the 21st. Generic models have gradually moved towards large-scale, multitask and multimodal starting from BERT in 2018. In recent years, top research institutions represented by Google, OpenAI, MSRA and Facebook have released large generic models for multitasks, achieving better results in downstream tasks than the traditional specialized model technology route. In November 2021, our Shanghai AA Labs generic vision technology system Intern, through more than 1 year of iteration, is now up to Intern 2.0, which is one of the best perception models.
Hello, my name is Jeremy Speth, and I'll be presenting work from Notre Dame on non-contrastive, unsupervised learning of physiological signals from video. As the heart beats, there are very small color changes and movements in the face that are detectable in RGB video. If we pass a video through a neural network, we can actually directly infer this pulse waveform. But typically, this requires supervised training. So we collect data from, say, a fingertip oximeter and synchronize it with a video and train the model on that waveform. But collecting this data is usually very hard and limits the sort of settings in which we can collect video. We present a method that exploits the sparsity of the pulse signal, since it's a strong periodic signal. It also only exists within a finite bandwidth, say 40 to 180 beats per minute. We come up with a method that can actually directly train models with just video and no ground truth.
Hi everyone, my name is Daniel McKee, and today I'm excited to share with you our work on language-guided music recommendation for video. Imagine that you're editing a video like this one, and you would like an audio soundtrack to be automatically recommended. Previous works have trained audiovisual models to recommend songs from a music database, like the following. The problem with existing models is that there is no user controllability over the types of songs recommended. In this work, we will investigate whether we can provide such control through natural language. For example, with our method, a user can query for hard rock featuring electric guitar riff and find the following.
Hello, My name is Hanlin Wang from Nanjing University. Thank you for your interest in our paper, PDPP, Projected Diffusion for Procedure Planning in Instructional Videos. We will first give a 1-minute preview. In this paper, we propose a diffusion-based model, PDPP, for procedure planning in instructional videos. Specifically, we remove the expensive intermediate supervision, and simply use task labels from instructional videos as supervision instead. The key insight of PDPP is to treat this problem as a distribution fitting problem and model the whole intermediate action sequence distribution. In addition, to model the uncertainty in procedure planning, we propose our PDPP based on diffusion models to introduce randomness to our learning process. Furthermore, we apply an efficient projection method to provide accurate conditional guides for our model during the diffusion process. Our PDPP model achieves the state-of-the-art performance on 3 datasets with different scales, even without the task supervision. Our model also has
Hello everyone, my name is Tanmay and I'm excited to introduce our work Visual Programming. It's a framework for solving visual tasks that require compositional reasoning by generating and executing programs. Imagine asking an intelligent virtual assistant to tag characters in a popular TV show. To solve this task, the assistant would have to detect faces in the image, retrieve character names from a knowledge base, match faces with these names, and draw label boxes on the image. This is a very complex task that requires multiple capabilities. In this talk, we describe our system WizProg, which effortlessly handles many such tasks by using a language model to generate Python programs. The programs can then be executed on the inputs to produce the desired result. To learn more about our approach, please watch our complete presentation.
Welcome to our paper, Super Clever, a virtual benchmark to diagnose domain robustness in visual reasoning. Visual reasoning requires answering the reasoning questions based on a given image. Current models suffer on out-of-domain testing. The models perform poorly on testing domains that are different from training ones. Domain gaps contain multiple factors. Those factors are entangled with each other, making domain gap hard to analyze. In this work, we propose a super clever dataset, which aims to study each domain shift factor separately. Super clever asks questions about vehicles randomly placed in the visual scenes. The dataset is controllable along these 4 factors, including visual complexity, question redundancy, concept distribution, and concept compositionality. Using Super Clever, we separately studied these 4 domain shift vectors on 5 models. Our findings suggest that modular training with probabilistic execution gives us the best model.
Hi everyone, I'm Pinaki, and I shall be presenting our paper, What Can Human Sketches Do for Object Detection? In this paper, we aim to explore the innate properties of human-drawn sketches for the fundamental vision task of object detection. Object detection has been there for over 2 decades with work as early as 2001 by Viola et al. This traditional object detection pipeline was later replaced by deep learning-based framework that brought with it improved performance but with an increased data annotation cost. Such heavy annotation cost became the focus of the next wave of literature with weakly supervised object detection requiring only image-level labels or no bounding box annotation. Despite this tremendous progress in object detection, something is missing: subjectivity. For long, object detection frameworks would detect anything and everything in its known set of classes. Users should be able to specify.
Hi, I'm presenting I2MV Farmer. In this work, we tackle the zero-shot learning task, where at training time, our model has access to a set of scene classes, and at test time, it needs to generalize to the scene set as well as a new set of unseen classes. We use a large language model to generate test descriptions of both our seen and unseen classes, and the intuition is that an image classification model can use these test descriptions to generalize to the unseen classes. We generate multiple descriptions of each class that reveal complementary information about a class. We use this with our I2MV former model. Our model aligns these descriptions globally with our I2MV global module and locally with our I2MV local search module. As we compare the performance of our model with baselines, we see that our model provides significant performance improvements over baselines. Thank you.
Most AI models only work across 1 or 2 modes, but our new ImageBind model works across 6: text, audio, images and video, 3D, thermal, and motion data. You give it input in one form and it can relate it to any others. It works more like our own imagination. If you give it a picture of a beach, it can find the sound of waves. If you give it a photo of a tiger and the sound of a waterfall, it can give you a video that combines both. This is a step towards AIs that understand the world around them more like we do, which will make them a lot more useful and will open up totally new ways to create things. We're open sourcing ImageBind so everyone in the world can access and build on top of.
We propose a progressive semantic visual mutual adaptation PSVMA network by deploying the dual semantic visual transformer module for generalized zero-shot learning. Early embedding-based methods embed category attributes and visual images and learn to align global visual representations with corresponding category prototypes. Some works apply attention mechanisms to highlight distinctive areas. More recently, semantic-guided approaches are proposed to employ the sharing attribute and localize specific attribute-related regions. However, these works neglect the semantic ambiguity problem. For example, for the attribute descriptor tail, the visual presentations of a dolphin's and rat's tail exhibit differently. Further, this semantic ambiguity can hamper cross-domain interactions.
Hello everyone, this is Qin Jiezhen from Northwestern Polytechnical University. I am happy to introduce our paper entitled PEFAT, Boosting Semi-Supervised Medical Image Classification via Pseudo-Loss Estimation and Feature Adversarial Training. Let's first talk about the motivation behind this work. As we all know, pseudo-labeling is a widely used strategy in semi-supervision for its simplicity and efficiency, but it has some drawbacks. For example, let's look at the left figure. We first warm up a model using labeled data, and then make predictions on both labeled and validation data. We can find that correct and incorrect pseudo-labeled data follow the similar probability distribution, which means it is hard to split a clean pseudo-labeled set using probability-based threshold.
Representing margin match, improving semi-supervised learning with pseudo-margins. Propose a method to improve semi-supervised learning for image classification. Previous state-of-the-art approaches, such as fixed match and flex match, use confidence thresholding as a means of ensuring high-quality pseudo-labels during training. That means, given an unlabeled example, we use this example only if the confidence of the models on the example passes a confidence threshold. In this paper, we design a better approach to ensure high-quality pseudo-labels by looking at historical predictions of the models and introduce the concept of pseudo-margins. Pseudo-margins extend the concept of margins to unlabeled examples, and we introduce average pseudo-margins, or APM, as a measure of correctness for pseudo-labels. Using this measure, we add an average margin.
Hello everyone, I'm Divya Madan and I'm going to present our work Heterogeneous Container Learning. This is joint work with Hongshu, Wanmin, Yan, and Pablo. Heterogeneous container learning is a framework that learns on a sequence of tasks while also adapting state-of-the-art deep learning advances into the container learning setup. We focus on the data-free container learning setting, where we assume that we don't have the access to the prior task data. To tackle this challenge, we propose two methods inspired from knowledge distillation and deep inversion, and show evaluation with methods that use buffer and without buffer on standard container learning benchmarks. We show that a proposed method, quick deep inversion, can interpolate between the current task, say bird in this case, to car in the prior case, generating examples in between both the tasks. To motivate further, . 。
Hello everyone, my name is Zheng Pan, a PhD student at Monash University. In this video, I will introduce our CVPR paper's Teachable Neural Networks. Today we have thousands of pre-trained models in ModelZone, but each model has a fixed computational graph. In reality, we need to deploy models to diverse platforms. So in this paper, our goal is to utilize these pre-trained models to cover many flawed accuracy trade-offs. So given a pre-trained model family, our method inserts a few stitching layers between these models. So in this case, we can cheaply produce many new networks with a few epochs of fine-tuning. So for example, by stitching DEIT models, we smoothly interpolate the performance between anchors. And furthermore, by stitching swing transformer, a single SNNet can challenge hundreds of pre-trained models in TRF.
Hello to all. Today we're presenting our work, Integral Neural Networks. My name is Kirill Solskih. Currently I'm working in the Stage AI Labs as the CTO. Today I will present our work with Azim Kurbanov. So let's start. What is integral neural networks? Integral neural networks is the new class of neural networks which uses integral apparatus instead of conventional layers. So integral neural networks utilizes smooth parameters representation instead of tensor representation. So why is such representation beneficial? So such representation allows fast resampling of pre-trained data and delivering structured pruning without fine-tuning. So the main idea could be understood through the simple Riemann integral. So here we integrate the product of two functions. We can write it as follows using some integration quadrature, doing the numerical integration. So and write this in the following way as the dot product of two vectors. So we can see that we can change the number of integration points and obtain different sizes of vectors. So while have the closed.
Hello everyone, my name is Zifan Wang. This video introduces our work in CVPR 2023. This is a joint collaboration with Nan, Tomer, Xi, and Radu from Google. In this work, we tackle the problem that deep networks are often vulnerable to human imperceptible noise from a learning theory perspective, that is perturbation. Our results include a set of analyses that guide us to minimize the trace of hashing of the robust loss with respect to the network's weights during training. The goal is to make the model more robust at the test time. We therefore provide a new trace of hashing regularization term, and using this term, we are able to improve the state-of-art test robust accuracy with reading transformers. If you found this work interesting, please feel free to join us in our poster session on Wednesday and with Nan, and